Hi, this is Leetcode question. Count the number of good subarrays, and this is the third question of weekly contest number 328. Given an integer array nums and an integer k, return the number of good subarrays of nums. A subarray is good if there are at least k pairs of indices ij such that I less than j and array of I equal array of j. For example, here we have this array and k equal 2, so we need to find all the sub arrays. The first good subarray is this subarray, which is the whole array, which is 3 1 4 3 2 2 4, and in this subarray we have the pairs 3 3 and 2 2 and 4 4, and so we have at least 2 pairs. Here we have 3 pairs, and this is greater than or equal to 2, so this is good subarray. Another good subarray is start at this index and finish at this index, which is 3 1 4 3 2 2, and this subarray has the pairs 3 and 3 and 2 2, so we have 2 pairs, and this is what we need, because k equal 2, this is valid or a good subarray. Another subarray is from 4 to 1, which is 1 4 3 2 2 4, which has the pairs 4 4 and 2 2, and again we have 2 pairs, and this is good array or good subarray. The last subarray is from 4 to 4, or you can start here from 4 to 4, which contains 4 3 2 2 4, and this subarray contains the pairs 4 4 2 2, and the number of these pairs equal to 2, and so this is valid subarray. And in total we have 1 2 3 4 good subarrays, and our answer should be 4 for this example. Now, how can we solve this problem efficiently? What we need to do is to use sliding window and store the count of the values in a dictionary. So we have a dictionary count, and we need to calculate the window for the first index, at which this window and the number of pairs will be at least 2. When it's at least 2, that means that this is valid window, and we break our loop then. So we need to calculate for the first index 3, and while iterating we will store at the count, and we increase the sum. So let's say we have sum equal 0. The first element is 3, and the dictionary initially is empty, count is empty, so we don't have any other 3, so the number of pairs stays 0, and we store for the element 3 that we have one element. Then we move to the next index. Here we have 1, and in the count we don't have any 1, so some stay 0, because for this one we cannot make pair with any 1 in the previous or the prefix array. So the sum remains 0, and we increase the number of ones in the count by 1, so 1 is 1. Then we move to 4. Again, there is no 4 in the count, so sum remains 0, and we increase 4 by 1. Then we have 3. Now 3, here we check, we have 1 3 already visited, and that means we can make 1 pair, so we increase our sum by 1, and we increase in the count the number of 3 by 1, so we have 2 3s. Then sum still less than k, we keep iterating. Then we have 2. The number of 2 here is 0, so sum stay the same, and we increase 2 by 1, or we increase the number of element in the dictionary, so now we have 1 2. Then we move to the other one. Now we have 2, and we have in the dictionary 1 2, and that means we can create a pair, 1 pair, so 2 and 2, so we need to increase the sum by 1, and sum become 2, and we have 2 2s. And here we break our loop, and so for the first index up to this 2, we managed to get 2 pairs, and so any index after that, and including this one, will be valid subarrays for all the subarrays starting at the 3. So this is valid subarray, this is valid subarray, because for sure it will have at least 2 pairs. And so we increase our answer. Imagine our answer is 0. We increase it by 2 here, which is n minus index, so this is the index, and 1 2 3 4 5 6 7 minus 0 1 2 3 4 5. So we have 2 elements here, and that means we have 2 valid subarrays, so answer become 2. And until now we calculated the window for the first element, which is 0, and we calculated the number of good subarrays starting at this index. Now we need to take advantage of this and calculate for 1. So we need to loop over all the elements and move the window. So for element 1, we come here. So what are the subarrays that start at 1? Now when we moved from 1, we lost number of pairs, 3. For 3, we lost how many pairs here? We have how many 3s here? We have 2. Then that means we lost 2 minus 1, 1 pair, when we moved from 3 to 1. So this becomes 1, and so we need to move the end until the sum becomes 2 again, or greater than 2. And this is what we are doing in this while loop. So our index is here, this is the end. We need to check the next element, which is 4. Now 4, we have one element here, and that means that we can create another pair from 4. So we increase the sum, so the index become here, and we increase the sum by 1, which is 2, and then we have 2 4s. 2 is 2 equals to 2, and that means we break for this index and all the subarrays from here to the index here. So all the subarrays are valid, and the number of subarrays is again n, which is 7 minus the index. The index is here 6, so we have one subarray, which is this one, which is 1. So the number of valid or good subarrays start at 1 is 1, so we increase the answer by 1, so the answer becomes 3. Then we need to check for 4, and remember our window is from 1 to 4. So when we move to 4, how many pairs we lost by moving from 1 to 4? In the count we have 1 1, and 1 1 doesn't make any pairs, so sum remains as is. We did not lost any pair, and so again the index remains here, and 7 minus 6 equal 1, and we add it to our answer, which is 4. Then we move to the next element, 3, and remember our window is up to here from 4 to 4. Now when we moved from 4 to 3, how many pairs we lost is the number of pairs, the count of 4 in the dictionary minus 1, so 2 minus 1 equal to 1, so the sum become 2 minus 1, which is 1. Here we lost 1 pair, 2 minus 1 is 1. Now we need to increase the end of the window until the sum equal 2, but here this is the last element in the array, and this means we cannot or there are no valid or no good subarrays start at index 3, and the same for 2, the same for 2, the same for this 4, and so this will be our final answer as shown here. So again, looking into the code, this is the dictionary to store the count when we calculate the window for the first index, and we assign n minus index to our answer. Now we need to loop and use this window. We need to loop from 1 to n, and we do count of the previous number minus 1, because when we move from, for example, here to here, we lost this one, so we will decrement the count of that index, and we lost the number of count. We lost this value of pairs, so it subtract from sum count of j minus 1, and we need to move the end of the window until we make the sum again equal to at least k. then we add to our answer n minus d.